Before it started, there was nothing, no time, no space. And then you had the Big Bang, this singularity. The entire universe fit into the size of a pinprick. It was unimaginably hot and dense. You had a soup of elementary particles, photons of light, protons, neutrons, electrons, and their antiparticles. They were all scattering and colliding and annihilating, and not even light could escape. My name is Marieke Navin. I work at the University of Sheffield. I'm a PhD student and I work on a neutrino oscillation experiment. I read about FameLab in the Institute of Physics magazine, and I actually read about it last year and really wanted to apply last year, but I was a bit too scared. So I just watched the progress of the finalists on the website, and this year I've plucked up the courage and went to the York Heat, and I got there first thing in the morning, 9 o'clock in the morning. I was the first to go. And I thought it was absolutely brilliant. I received really excellent structured feedback on how to improve my talks. I got through to the final in the afternoon and I thoroughly enjoyed the experience and I was absolutely thrilled to win. I think science communication is really important. I'm especially interested in trying to encourage more girls to study physics. There's not many girls interested in physics. They all think it's too hard and it's sort of dominated by men, which is true. So I hope that by putting myself out there and giving talks to school children, I can encourage more girls to do physics. Our planet is being constantly bombarded by cosmic rays. It consists primarily of protons, which are the building blocks of atoms and matter. Although a proton has a diameter of less than a millionth of a billionth of a metre, the most energetic cosmic rays can have the same amount of energy as a tennis ball hit by Tim Henman. When a TV picks up noise like this, a few percent of that noise comes from photons that originated at the first light of the universe. This happened a few 100,000 years after the Big Bang. Before this time, photons of light were embroiled in a plasma-like cosmic soup with protons and electrons, and light couldn't escape. Since this first light, or last scattering, the universe has continued to expand and cool for 13 billion years, and now we can pick up some of that radiation on our TV sets, or by sending extremely sensitive satellites into space. When I'm preparing my talk for the final, I'm going to concentrate very much on not trying to fit too much into the 3 minutes and to pause and let the audience interact a little bit. I think in the past I can sometimes try and grab as much science into 3 minutes as I possibly can, and I've learned this weekend that that's not what I should do, and it's more about how you say it, even more so than actually what you say sometimes. Well, maths is stuff. I'm maths, you're maths, a cup of coffee is maths. But what is stuff? And what gives stuff its stuffness? Well, I don't know if you're like me, but if you want to know the answer to something, you might take something apart and delve around inside. Does anyone do that? Well, that's exactly what we do in particle physics.